Hello, you right? So we're going to do a little introduction. We've done expansion and contraction, and then we're going to look at some of the ways that heat gets transferred through substances. So the first one we're going to look at is this phenomenon called conduction. So for your notes, easy peasy. Sorry, here we go. Title then, conduction. So conduction. Pause the video when you need to and write the notes and use the notes to help you write diagrams and explanations, yeah? So for your notes, we're learning about thermal energy transfer in solids and why that happens. What are conductors? What are insulators? So thermal energy is transferred from hotter objects to cooler objects. So energy always flows from an area where there is lots of energy to where there is no energy. Conduction, the key word that we're looking at today, is one of the ways which thermal energy is transferred. So conduction requires the transfer of energy from one particle to another particle that's touching it, okay, from a hotter object to a colder object. Solids are better conductors than liquids and gases, and also some solids are much better conductors than others. Okay, so there's four main points that we're going to work through, okay? So point number one, let's look at some diagrams that help us explain. So transfer of energy during conduction. So these diagrams here, I want you to draw these. And we're going to say during conduction, the transfer of energy goes from hot. So if I was heating this with a Bunsen burner, this end would be hot, and the energy transfer would be towards the cold end. After conduction, let's say if I stopped heating it, now the entire solid would have an equal temperature throughout the whole solid. So this would be warm. So the heat's moved through the substance. There's no hot, there's no cold, it's all the same temperature now. Okay. So a really good thing to note in this diagram is that at the hot end, we can see that these particles here are actually vibrating a lot more. They're taking up a lot more space, and we know that from the expansion topic that we did. Okay, so these are now vibrating a lot more. What's happening is the vibration is being passed along from particle to particle without the particles moving from their places in the material. They're just knocking into the next one. Okay, so energy is being transferred from particle to particle. They have to be touching in order for this to happen. So energy can get passed through the substance as the particles bang into each other and knock into each other. So heat energy is essentially transferred into kinetic energy. The kinetic energy is bounced along the particles in a row towards the cold end. So by the end of this, all of these particles will be vibrating more than they were before, right? Because they're warmer. Okay, this explanation here is a good paragraph to have. Okay, so why are solids better conductors than liquids and gases? Well, we know how solids are arranged, right? They're all touching each other. Look, these particles here are all touching each other. Liquids, some of them are touching, but a lot of them are not touching. They're not in a regular arrangement, so it's much harder for energy. If I was going to heat this end, and this is the cold end, it'd be much harder for energy to get from one end to the other because the particles are not touching each other. Similarly, in gases, if I was going to heat this end, it'd be really hard for this one to bump into this one and pass on its kinetic energy because the particles are so far away from each other. And in a vacuum, it's impossible for conduction to go through a vacuum because there are no particles. So conduction does not happen in space. There are no particles for the energy to be passed along. In gas, conduction happens very, 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 very slowly. Gas is almost more like an insulator than it is a conductor. Liquids, yeah, it maybe conduct a little bit if the liquid is dense enough. But solids are much better at conducting heat than any of those other states. Okay, so another key word there, vacuum, is an area where there is no particles. And a thermal insulator and a thermal conductor, we could describe these. We'll investigate these later on. A thermal conductor is one that is very good at conducting heat, and a thermal insulator is one that is very bad at conducting heat. Like so, thermal conductor would be stainless steel or copper, and a thermal insulator might be wood or polystyrene, maybe. Okay, so those are the keywords here. That should be in your notes, those keywords. Okay. These keywords here, these two diagrams, and potentially these diagrams here to show how some materials are better conductors than others. Okay, I hope that helps. That's your notes for today. Hopefully we'll move on to an experiment later on in the week.